I don't care. I don't care anymore. Okay. So this again says sketch the graph of the f prime of x. You have 4 book problems to do today, 4 book problems to do. And all you have to do for all of them is what we're about to do right now. Okay. And wow. Yes, I am. Oh my gosh. Okay. So if I were to take, remember when I say derivative, you say what? Slope. Okay. So if I take a slope at this point, if I were to draw a tangent line at this point right here, would my slope be positive or negative right there? Negative. What about here? Negative. Here, still negative. What about here? Might draw a tangent line. Wouldn't it go like that? 0. Okay. So I'm negative right here before what point? What point am I at 0? -2. I know it doesn't look like it. It's supposed to be there. That's a slope of 0 right there. Then what happens to my slope right now? Where am I at now? Positive, positive. Up until where? Until 3, I have a 0 slope. And then what happens after that? Back to negative. Okay, this is important. So I want to, actually I didn't write positive. Let me write positive here and then negative here. So you are going to sketch a graph for me, just to sketch. I don't need it to be completely accurate. I just need to represent the where the function has a positive slope, a negative slope, and a 0 slope. So when you go to sketch a graph, here would be your x-axis, okay? Your zeros, remember what that term means from pre-calculus? If you take that 171, you do. Your zeros are x-intercepts. So you have zeros at -2 and at 3. Would you all agree? So when my derivative at -2 is equal to 0, the slope is 0. The slope at -2 is 0. We already talked about that. The slope at 3 is also 0. So they're your x-intercepts. Slopes are 0. Everything before -2, what kind of sign were you? What value were you when you were before -2? Right before here. What kind of slope were you? You were always negative. So your slope of the function was less than 0 or was negative from -infinity to -2. You had a negative, so you're down here, which is negative. We'll call it like that. But between 2 and 3, what kind of slope did I have between 2 and 3? Positive slope. So my slope function was bigger than 0 when I was between -2 and 3. And then what was it after 3? Negative again. From 3 to infinity. Okay. So how do I draw this? I mean, all I need to see is something like this. Go up and come down. I'm negative. I'm in the positives. I'm back to being negative. That is the sketch. That's all I need. I'm going to do another one with you so you can understand. Yes. Never mind. Okay, never mind. And by the way, all this you don't need. We are actually going to do this more in chapter 4. It's called applications of derivatives. I just need this part right here. Yes, Braxton, darling.
So on your graph that you just did, the values need to be negative, not the slope.
Correct. Yes. Well, the values are the slopes. This is the slope one. Okay. All right, let me do another one. 66. Yes, darling.
Over here, one. I said that too.
Just one. This is actual problem number 66 in your book. Hopefully I can draw it correctly.
I feel like there's a definite catch.
It's not. There's never a catch. Oh, that looks terrible, but whatever. All right, we are going to graph the derivative. We're just going to do a sketch of it. That's all it is. So the main thing is to first find your zeros, right? Those are what you want to plot right here. Where are your zero slopes at? Well, actually, it's negative 1.5. I know, but in the book, it's negative 1.5. Sorry. My graph is terrible. It's right here. Where's there another zero? 0. Where's there another 0? 1.5. Yeah, sorry about that. You'll see if you actually look at number 66. Much better than mine. They have the nice grids there. Okay, question. Before negative 1.5, what kind of slopes are these? Right here, right here. If I were drawing tangent lines, wouldn't they all be positive? Okay. Between negative 1.5 and 0, what kind of slopes are these? Negative. Between 0 and 1.5, what kind of slopes are those? And between 1.5 and beyond, wouldn't you agree these are all going to also be negative? So if I were to just sketch this out, I would just come from positive direction, hit negative 1.5, be in the negative direction, come back up and hit 0, be in the positive, come back down and hit negative 1.5. And what I want to show you is the following, because this is going to help you out with what we do tomorrow. It'll make more sense, I believe. Do you know what degree polynomial this is when it's a W or an M? What degree is that? Degree 4. Do you know what degree this is when it's like that? A snake almost? 3. Okay, let's go up here. What degree is this? 3. What degree is my derivative?
2.
So what can you tell me about the derivative function in terms of degrees? It goes what? Down 1. It's going to be very important because that's how we do what's called the power rule tomorrow. We always go down a degree for a derivative, okay? So you have to do 3 more problems like that. I just did the one for you. Can you handle that? Sure you can. There's nothing too much to it. Yes. No, I'm showing you this because, so the SPCC test, she's going to give you this and she wants you to sketch it. Get ready. It's going to be fun. Okay, now for this second part, we're going to work on one theorem and then I'm going to give you your homework worksheet part and that's going to be it. And the theorem the title is actually the definition, the theorem itself. The title says differentiability implies continuity. Differentiability implies continuity. However, not vice versa. If you can take a derivative at a point, then you are continuous at that point, but not the other way around. Just because a function is continuous does not mean it has a derivative at that point. And I'm going to give you an example in a moment of that. But here's what the definition says. If f of x is differentiable, differentiable, you would think I know how to spell this. At A, then f is continuous. But I'm actually going to give you 3 pictures where that's not working the other way. Meaning, so you all know what this shape is. That is your good old absolute value. Would you all agree? Okay. The absolute value, if I were to ask you, is this continuous? You would tell me, yeah, I can put my pen on it and it keeps going. Okay. However, at this point right here, A, it is not differentiable. This is called a cusp, okay? In mathematics, a sharp corner, or a cusp, you cannot take a derivative at, okay? So this is continuous, yes, but not differentiable. You've got to know this because you'll see we are gonna end up with some points where we can take a derivative and some points where we can't. Vertical lines, like that. Vertical lines are continuous, but you cannot take a derivative of a vertical line. They are not differentiable. And think about it again. If I said, what's the derivative of a vertical line, or what's the slope, you would tell me what? What's the slope of a vertical line? Undefined, right? You'd be like, it's undefined, right? So we can't really take a derivative there. We don't know how to deal with that. So vertical lines are not differentiable. There's another type of vertical line. You've seen it before. It's in like, even though it's kind of like a vertical line, it's actually, if it was really, I should have made this really more straight. This right here is also considered a vertical line, just so you know, if you see a picture like that. So you cannot take, at this point A right here, you cannot take a derivative at that point. All right, so cusps, vertical lines, sharp turns, sharp corners, you can't take a derivative at. So I'm gonna hand out this homework to you. We're going to do the front page together. Yay! And then the rest of that and the bookwork will be yours. All right, let's talk about this. Most of you midway. Let's start with A. At this point 3, is this function continuous? No. Can you take a derivative then? No. Taking derivative implies that it's continuous at that point. So neither is the correct answer for A. B, is this function continuous? No, it has a limit. It has the same limit, but it's not continuous. There's an open hole right here. So it is not continuous, which means it's not differentiable, which means neither. Okay, how about C? Is it continuous? Yeah, so continuous. Is it differentiable then at that point? It sure is. Okay. All right, so D is a little tricky. When you go from like a linear to like almost like a curved quadratic point right here, they consider that like a sharp turn, switching gears. So right here at this point, you're not differentiable. You are continuous though, right? I could still move my pen along the whole entire thing. So I am continuous, but that point right there is not good. It's not a point that I can actually take a derivative at. How about E with an asymptote? It's not continuous, that's for sure. It's not differentiable then at that point. Did I not just draw this one for you? Okay, so is it continuous? Sure is. But is it differentiable? No. Okay, it's called a cusp, yes. Okay, this point G is exactly like D. It goes from like a linear and then turns like that. So this is considered a non-differentiable point. We can't take a derivative there, but it is continuous. And then this point, this H line right here, do you see like how I could draw this vertical line right there? And that would not be good. That means I have an undefined slope. You can't do that there. So it's continuous, but it's not differentiable at that point. So again, just this idea of, are you continuous, are you differentiable? You need to understand that. Let's go to 21. Looking at this graph right here, could you tell me the points where it seems to be continuous, but you can't take a derivative? So let's start to the left. Am I continuous? What was that point right there? It's a sharp turn. So that point right there is negative, what was it? -5? Yeah. It's continuous, yes, but we have a problem there, okay? All right, let's go up here. Any other sharp turns or anything going crazy?
2.
At 2. Anything else after that? No, we just have a bunch of jumps and asymptotes and stuff like that. So then now let's do part B. Tell me where the function is neither continuous nor differentiable. Negative what? 3, because there's a jump. Where else? 5, because there's a jump there. And where else? The asymptote. Good job, y'all. All right, 22. Discuss the continuity and the differentiability of the function f of x equals the absolute value of x minus 2. You should know what this looks like. Absolute value of x minus 2 is a V shape that's been shifted over where? To the right 2. Is this function continuous? Yes, continuous. Is it differentiable? Not differentiable at x equal 2. That's what you write. Okay? And one more here before we do our final example. Discuss the continuity and differentiability of the function x to the 1/3. Do you know what x to the 1/3 is? What that graph looks like? You should. That's that cubic one. It kind of goes like this. It's the cube root. Looks like that. Okay, actually it kind of does more like that. And this goes, again, with this whole idea of it is continuous. We're good. We have a beautifully line. But right here at this point, we have this vertical slope, and I didn't draw it as accurately as I should have drawn it. You can look in your calculator. But it's not differentiable at x equals 0. Okay, so this theorem is very important. Now, I am going to be so kind to you. I have intended you to do 24, 25, and 26. But if you can bear with me and I will do one problem for you, you will not have to do these 3 then. And all you'll have to do is the multiple choice parts. These are all multiple choice and they go very quickly. All they're asking you is it differentiable? Is it continuous? Is it differentiable? Is it continuous? Very easy. Okay. But you have to pay attention to what I'm about to do, which is important. Here's why. This problem is so much easier to do with what we learn tomorrow. That's why. The trick to doing derivatives is so much easier than doing it the long way, but you have to know how to do it the long way. It's the joy of mathematics, okay? So our last and final example is this one. Find if f of x is continuous and or differentiable given f of x equals the negative x squared plus 2 for x less than or equal to 1 and x for x greater than 1 at the point x equals 1. I want you to tell me if this function, and I want you to do this algebraically, not necessarily graphically. Graphically is fun and it's easy, but now we have to actually prove it. I want you to tell me, is this function continuous? And can I take a derivative at 1? Okay. So algebraically, how do I show this? Let's go back to the last test. How did we find out if something was continuous? Do you remember? It was a 3-step rule. Plug it in. And then find the limits and then see if those are the same. Okay, so we'll start with that one because that's actually the easier one. Where do I plug 1 into? Top, and what do I get out? What's the f of 1? Negative 1 squared, which is 1, plus 2 is 1. Okay, so plugged it in. Let's find out if the limits are the same. Let's see if the limit from the left is equal to the limit from the right. So what does that mean? Plug 1 into the top. Didn't I already do that? Get 1. Plug 1 into the bottom. What do you get? 1. What's the limit then? 1. Are those two numbers the same? Am I continuous? So you would say, yes, continuous. Now we need to decide if we are differentiable. Differentiable is very similar. Differentiable at x equals 1. What you do is you have to take the derivative for a piecewise. You have to take a derivative of the left or the top and see if it equals the derivative on the right, on the bottom. The algebraic way of writing that would be the d dx of the function f of x evaluated at x equals 1 for the left. Is that the same as the d dx of f of x evaluated at x equals 1 for the right? How do you take a derivative, children? If you did your homework, I won't mention any names. Great, was Camden.
F plus F.
Oh, remember this formula you should have written 20,000 times last night? As h goes to 0 of f of x plus h minus f of x all over h. Friends, that is the derivative. So you have to take the derivative of the top and the derivative of the bottom. The bottom one's easy. We're going to do the top. You're welcome. Pay attention. Okay? So we'll start here on this side. What is my f of x plus h? Oops, let me bring that down. What would I do with x plus h? Where would I plug that into? Wherever there's an x on the top or on the bottom? Top. Okay, so negative x plus h squared plus 2. And then you got to clean that up. So negative x squared, I'll do it for you, 2xh plus h squared plus 2. And then you got to distribute the negative through. Negative x squared minus 2xh, minus h squared plus 2. That, my friends, is just f of x plus h. Again, if you did your homework last night, what did you do after that? Minus what? Minus f of x. And if you want me to write f of x, I'll write it as negative x squared plus 2. So you need to, of course, I'm running out of room. I'm going to have to go into this right side. So you have to do f of x plus h minus f of x and put it over h. So here on this little part right there, I would put negative x squared minus 2x minus h squared plus 2 minus, well, actually that would be plus x squared minus 2. That's what my top would be. What does that clean up to become? Goodbye, 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 goodbye. What is negative 2xh minus h squared on top over h reduced to? Minus h. And then take the limit now as h goes to 0. What are you left with? Negative 2x. Okay? And what am I evaluating x to be at? What point? 1. So what is the slope on that side? Negative 2. So the slope is negative 2. Wait until tomorrow when I teach you the trick, because you could have done this in literally 2 seconds. And instead they do this whole thing. That's why I'm saving you right now, okay? But I want you to do the derivative of the right now. Okay? You have to do this one. This one's much easier. If you did last night's homework, this one's much easier. Do the derivative of the right, which is the derivative of this guy. It's very quick. F of x plus h minus f of x over h. 1. So what is the slope on that side? 1. So I have 1 on this side, but I have a slope of negative 2 on this side. This is not differentiable. Not differentiable. Now, you are just so welcome. Thank you for bearing with me. You do not have to do number 24, 25, and 26. You're welcome, because if you had done them the hard way, it's so much easier to do it when we learn it tomorrow. But you do have to do all the multiple choice here. That's really easy. The multiple choice is just asking, can you take a derivative? Can you not take a derivative? Whatever you got. And then don't forget about the 3 problems. And that's it. All right? Now you can go back to your regularly scheduled election coverage, John.
Let's hear it. Can I use the restroom?
You can. Can you flick on